Today we're going to talk about graphs of functions. This is the last section of chapter 2, so section 7, and we'll start with review of all of the different types of functions, then we'll do a little bit of graphing, and then we'll review how to find x and y intercepts, and then tomorrow during class we'll do some practice with each of these. So the first thing we're going to talk about is a quick review of linear constant functions, and we're going to say let m and b represent real numbers such that m is not equal to 0. If that's true, then we have f of x equals mx plus b, also y equals mx plus b, and we know that to be a linear function. If m were equal to 0, then we would have the function y equals b, or y equals c, or y equals some constant number where f of x equals, and that would be considered a constant function. Constant function and linear functions are often talked about together because they both are graphs of lines. Okay, so let's go ahead and review all of the parent functions, and then we're going to talk about transformations to those eventually. So the first one is y equals x, or f of x equals x if we use function notation. And this, of course, you recognize as a linear function. Specifically, this is known as the identity function. Okay, and so, we would go ahead and look at a graph of this. The line y equals x has an unlimited domain, which means all real numbers, and its range is also the same. The next function is y equals x squared, a quadratic function, one that you're probably very familiar with. And so that's the graph y equals x squared. So we'll identify that as quadratic. And let's quickly talk about the domain of this parent function. So I have a graph here. We have too much glare on there. So y equals x squared, you can see its domain, or its x values, are pretty much unlimited. Any x value could be plugged in there. And then in terms of the y values, we have a lowest y value, and that y value would be the lowest starting at 0 and then going up to infinity. Okay, so our domain would be similar to the identity in that it's unlimited, all real numbers, but our range is from 0 to infinity, including that 0. So again, just a reminder, in interval notation, inclusive means that we would use a bracket. Okay, the next function hopefully should be somewhat familiar as well. We have x cubed, which we would call a cubic function. And just like the previous two, it has unlimited domain. And let's take a look at its graph. Okay. And so we have y equals x cubed. You can see not only is its domain unlimited, meaning all possibilities, but its range, or the possible y values, is also unlimited, or all real values. Okay, the next one is the absolute value function. And we spent a little time discussing absolute value when we were doing our domain range activity. Let's see if I can get some color. Here we go. Just as a quick note, I'm gonna add a new page. Whoops. So I'm gonna add a new page, a new graph page. Okay, and then to get absolute value, in order to graph it, you have to, you can do a couple of different things. You can always go into the catalog, but you can also press the button right next to the catalog and it should give you a bunch of choices. And so you're just gonna move your mouse until you get to the absolute value symbol. And then once you press enter, it'll give you the absolute value bars. So then you can go ahead and have your absolute value equation. And hopefully this looks familiar, the absolute value equation. And so again, just like our previous ones, any x value will yield a value on the y. Now, unfortunately, in terms of the y values, we have a lowest point or a lowest value in the range, which would be again 0, and then to infinity. Okay, so we'll express that domain just like the domain of the previous ones, from negative infinity to infinity. And then our range is similar to the range of a quadratic. And then once we start talking about transformations, we'll see how these potentially change. Okay, the next one is what we would call the square root function. And let's go ahead and take a look at that domain. Okay, so we'll put in the square root of x. Okay, I'm going to get a window that this is a pretty good window. Now you can see for this, the square root function starts here, right? So it's starting at this value and then continuing on. Now if I were to look at the table, so if I add a table on here, I can see that as I scroll through the table, anything after 0, it's telling us undefined. So that's helpful because that can help us to determine our domain and range. And in this particular case, our domain starts at 0 and goes to infinity, and then our range is the same. Now, what's the reason for that? Well, we know that we cannot take the square root of a negative number. So if we had a negative under the radical, it wouldn't be possible. So that's why our domain is all real numbers greater than or equal to 0. Okay, and then the last function is what we would call the reciprocal function. Okay. And with the reciprocal function, we have a fraction. So we have to worry about some specific things happening when we're dealing with a fraction. Okay, and so you notice this is a somewhat unusual graph because we can't have 0 in the denominator. And so if you can't have a 0 in the denominator, then there's no, and we already know that 1 is in the numerator, there's no way that we could get this function to equal 0. So 0 is not part of the domain, nor is it part of the range. Okay, so how do we express everything except 0? Okay, so that means we have from negative infinity to 0, and then from 0 to infinity. Okay, that's everything except 0. So that means all real numbers excluding 0. And then we would do the same thing for the range. Negative infinity to 0, union with 0 to infinity. Okay. Now, we've already seen each of these graphs as I went through and described those. Okay, so we're going to skip over those, and then we're going to come to the back of the second page where we're going to do a quick review of some of the things related to a quadratic. Okay, so quadratic function is y equals x squared, or f of x equals x squared. That is your parent function, the one that all the transformations are performed on. We also can define a quadratic function as f of x equals ax squared plus bx plus c. A, B, and C would have to be real numbers, and A cannot equal 0, otherwise we wouldn't have a quadratic function. So just a couple of quick reminders here. It's talking about the graph of a quadratic. If the leading coefficient, the A value, is positive, then the parabola will open upward and you'll have a minimum point. Okay, so a little quick sketch. You'd have parabola opening up, and then this would be your vertex, which would be at the lowest part of the graph, or the minimum. If A value were negative, then you have a reflection or a flip of the parabola, and so then your vertex would be here at the top, and that would be a maximum. And here we said it was a min. Okay. So there's a lot of different names for the vertex. You might hear people call it the turning point, the vertex, minimum, maximum, depending on whether or not it's a minimum or maximum. So all of those essentially mean the same. On the calculator, if we're trying to calculate or find that vertex, we will be calculating either the minimum or the maximum, depending on the graph. Okay, and then the last piece is the axis of symmetry. So make sure you in some way note that formula, x equals negative b over 2a, and we'll practice with that in class. Okay, the last thing is identifying x and y intercepts of a graph. In order to find the x-intercepts, that means that you are on the x-axis. On the x-axis, the value of y is 0. So essentially, you're finding or evaluating the function when y equals 0. Okay. To find the y-intercepts, a point on the y-axis, that means x equals 0. So remember our function notation, f of 0. This means the value of the function evaluated when x equals 0. So we'll put a note, x equals 0. Okay, I'm going to stop there, and then tomorrow in class, we're going to go ahead and find the x-intercept, y-intercept, graph the function. Cleaning time, once you shut off the video, I'd like you to take a few minutes to go through and answer I think you can do it pretty quickly, numbers 1 through 9. It asks you to identify the functions as linear, constant, quadratic, or none. Okay, so I'd like you to take a look at each of those and identify them based on what you know. I'll see y'all tomorrow.